Hi guys, welcome to today's tutorial. Today we'll be looking at number-based systems. So stay with us as we go through this teaching with various examples. Alright, now talking about number-based systems. Number systems are made up of different digits. Okay, now each digit in a number system cannot be greater than the number system. Okay, that's why you say that the highest digit of any number system is one less than the base. So if we say we are working in base 2, that means the digits in base 2 cannot be greater than 2. It will be 2 minus 1. So the highest digit in base 2 will be 1. Now, examples of number systems and their digits. Now, we have our number system base 2. It is popularly called binary system. Now, the digits of our binary system are 0 and 1. Now, since it's in base 2, the digits, you can see we don't have 2. Okay, it's just having 1 and 0, which is in base 2. So this statement, it confirms this statement that the highest digit in any base system is 1 less than the base. So if this is base 2, the highest digit will be 2 minus 1, which will be 1. If we talk about base 3, the highest digit will be 3 minus 1, that will be 2. So for digits in base 3, we'll be having, for base 3, we'll be having our digits at 0, 1, 2. So if we talk about base 4, we have our digits as 0, 1, 2, 3. If we talk about base 5, we have it as 0, 1, 2, 3, and 4. You can notice that all base, the highest digits are 1 less than the base. So and so on and so forth. So talking about base 8, which is called our octal system. Our octal system is digits are 0, 1, 2, 3, 4, 5, 6, and 7. Okay, still following the same rule that the highest digit is 1 less than the base. Now base 10, which is known as a denary, some textbooks refer to it as decimal system. Okay, but we refer to some others refer to it as denary system. Now they are one and same thing. Now the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, now our base 12 is known as our duodecimal system. Duodecimal system. And the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, and C. Where our A is 10, B is 11, and C, okay, and C is 12. So if C is 12, this shouldn't be here. So our decimal 0, for duodecimal will be 10 and 11, which is A and B. Okay, now for our base 16, which is hexadecimal system. Our hexadecimal system will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A, B, C, D, E, and F, where our alphabets represents 10, 11, 12, 13, 14, and 15, and so on and so forth, up to base 20 and the rest of them. Alright, now from here we'll be looking at how to convert from one base to another. Okay, conversion of from one base to another, and how to reconvert using our two methods. We have two methods of converting from one base to another. We have the expansion method. We have the expansion method, and 2, the division method. So we'll be looking at these two methods of converting from one base to another. Alright. Our first example looks at converting from base 2 to base 10. Now, it is important to know that when converting from base 2 or any other number or any other base to base 10, first off, you're multiplying those numbers by the base raised to the power to which it is going to be labeled. Now, what do I mean by that? Now, since we have here 101, alright, this is our units, tens and hundred. Alright, okay, so if you are expanding this will become 1 times the base 2 raised to power 2 plus 0 times the base 2 raised to power 1 plus 1 times the base 2 raised to power 0. Now, 2 times 2 will give us 4, so this will become 1 times 4 plus 0 times 2 will give us 0 plus anything raised to power 0 is 1. So 1 times 1 will give us 1. So this becomes 4 plus 0 plus 1, which will give us 5 base 10. So converting our 101 base 2 to base 10 will give us 5 base 10. Alright, looking at our next example that says convert 101.234 base 5 to base 10. Okay, now we are converting this to base 10. This we are going to do same way. We label from here our units 0, 1, 2. Now remember that from your decimals, okay, let me write this 101.234 base 5. This becomes 0, 1, 2. Alright? Now, remember that our numbers after our decimal are not whole numbers. Okay? They aren't whole numbers. So this becomes minus 1, minus 2, and minus 3. Alright. Having numbered this that way, now we are going to multiply each and every of this number by the base raised to the powers it has here. So this becomes 1 times 5 raised to power 2 plus 0 times 5 raised to power 1 plus 1 times 5 raised to power 0 plus 2 times 5 raised to power minus 1 plus 3 times 5 raised to power minus 2 plus 4 times 5 raised to power minus 3. Okay, now we can put this as 5 times 5 is 25, right? Which gives us 25 times 1 is 25 plus 0 times 5, 0 plus anything raised to power 0 is 1. 1 times 1, 1 plus, now this we can put in fractions. Okay, this will become 2 over 5 raised to power 1 plus 3 over 5 raised to power 2 plus 4 over 5 raised to power 3. Remember our fractional indices law, where we have it as 1 over x raised to power n will become x raised to power minus n. Now applying that law here, this is what we would get. Okay, now adding this, our whole number up will give us 26 plus 2 over 5 plus 3 over 25 plus 4 over 125. Okay, now from here we know that we have our 125 as our LCM. Okay, so this becomes 125 as our LCM. Alright, if this becomes 125 as our LCM, we'll now have this as, this will give us 25. Alright, now 5 into 125 will give us 25. 25 times 2 will give us 50 plus, alright, 25 into 125 will give us 5. 5 times 3 will give us 15 plus 125 into 125 will give us 1. 1 times 4 will give us 4. So this leaves us with 26 plus 65 plus 4, 69. 69 over 125. Alright? So this will give us a whole number of 26 fraction 69 over 125. Alright, that will be our answer. Alright, now you need to notice that for the whole fraction part, we left it out to add to the decimal point after getting our answer. Our next question says, convert 35 base 10 to base 3. Now, it is important to state that the first two examples we saw are expansion method. Okay, we expanded our equations, our numbers, to convert to base 10. That means when you're converting any number from base 2, any number in any other base to base 10, okay, you use your expansion method. But when you're converting from base 10 to any other base, you use your division method. Note, converting from any number to base 10, you use expansion method. So our expansion method is used for converting from any base to base 10. Okay, while division method is used for converting from base 10 to any other base. Now it's like a reverse of the expansion method. So we use the division method for converting from base 10 to any other base, and the expansion for converting from any other base, any base to base 10. Now looking at this example, it says convert 35 base 10 to base 3. Okay, now this we are going to have as 35. Since we are converting to base 3, will be divided by 3. Now 3 into 3, 1. 3 into 5, 1. Remainder how many? 3 into 5 will give you 1, remainder 2. So if you count 5, you remove 3, you have 2 left. So that remainder, we'll write it out. Now 3 here, 3 into 11 will give you 9. 3 times 3, 9. 11 minus 9. Okay, 11 minus 9 will remain 2. Okay, now 3 into 3 will be 1, remainder 0. And 3 into 1 cannot, that will be 0, remainder 1. Now you take your reading upward. Now this will become 35 base 10 will give you 1, 0, 2, 2 base 3. Now we've converted from base 10 to base 3. Okay, another example we can see is convert 214. Okay, we can convert 214 base 10 to base 5. Alright, if we have to convert this to base 5, this will give us 214 and 5. Now, 214 divided by 5 would give us 42. Remainder 4. Okay? 42, remainder 4. Now, 5 here would give us 8. 5 times 8, 40. Remainder 2. Now 5 here again will give us 1, remainder 3. 5 here will give us 0, remainder 1. Read upwards. Now, 214 base 10 would give us 1324 base 5. Alright, now this is how you convert from base 10 to any other base using your division method. If you've watched with us up to this moment, don't forget to like, subscribe, and click on the notification button for more updates. Our next example talks about converting the decimal part of a number in base 10 to any other base. Now, it is important to note that when you're converting a decimal fraction from base 10 to any number base, we multiply this decimal part alone by the base which we are converting it to. Alright, so for example, for this example we have 0.625. Alright, now we'll start with times 2. Okay, now 2 times 5 will give us 10. Write down 0, carry 1. 2 times 2, 4, plus 1, 5. 2 times 6, 12. So we write down 2, remainder 1. Okay, so now here we multiply again by 2. Now 2 times 0 is 0. 2 times 5 is 10. Write down 0, carry 1. 2 times 2 is 4 plus 1. 4 plus 1, that will give us 5. Remainder 0. Alright, now the next one, the third time, since there are 3 digits, we have times 2. Okay, this will give us 2 times 0, 0, 2 times 0, 0, 2 times 5, 0, remainder 1. Okay, now we've gotten this, we'll now read downwards. Remember, using our division, we read upwards. Now we are reading downwards. This becomes 0.625 base 10 would be 101 base 2. Sorry, 0.101 base 2. Alright. And next question says convert 0.526 base 10 to base 8. Now in converting this, we have 0.526. Remember, we said we'll multiply the decimal part by the base to which we are converting it to. So this becomes times 8. Alright, 6 times 8 will give us 48. Write down, excuse me, 8, carry 4. 8 times 2, 16, plus 4, 20. Write down 0, carry 2. 8 times 5, 40, plus 2, 42. Write down 2, remainder 4. Now, times 8 again. 8 times 8, 64. Write down 4, carry 6. 8 times 0, 8. 8 times 0 is 0. 0 plus 6, 6. Now, 2 times 8 is 16. Write down 6. Carry 1. Now, times 8 again. 8 times 4 is 32. Alright, we write down 2. Carry 3. 8 times 6, 48, plus 3, 51, write down 1, carry 5. 8 times 6, 48, plus 5, 53, we write down 3, carry 5. Now, we can stop here, or we can do just one more, multiply by 8 again. Okay, 8 times 2 will give us 16, write down 6, carry 1. 8 times 1, 8, plus 1, 9. 8 times 3, 24, write down 4, carry 2. Now we read downwards. This gives us 0.526 base 10 will give us 0.4152 base 8. Alright, next we are going to look at how to convert from one base to another base which isn't base 10. For example, we have convert 213 base 4 to base 2. Okay, we have it to base 2. Now, if we are converting 213 base 4 to base 2, that means we will have to first of all convert base to base 10 before we can convert to base 2. In other words, for you to convert from one base to another base, you first of all convert to base 10 before you convert to base 2. Alright, in doing this we have 213. Remember, in converting to base 10 we use the expansion method. 0, 1, 2. This becomes 2 times 4 raised power 2 plus 1 times 4 raised power 1 plus 3 times 4 raised power 0. Now this will give us 2 times 4 raised power 2. 4 times 4 is 16 plus 1 times 4 plus 3. Anything raised power 0 is 1 times 1. 16 times 2 will give us 32 plus 4 plus 3, which will give us 4 plus 32 will give us 60 and 36. 36 plus 3 will give us 39 base 10. So we have this as 39 base 10. Now, since we've converted from base 4 to base 10, we can now convert from base 10 to base 2 using the division method. Now this becomes 39 and 2. 2 into 39 will give us 2 into 3, 1, remainder 1. So 2 into 19 would give us 9. Now that's 2 times 9, 18. So this will give us 9, remainder 1. Now 2 into 19 would give us another 9, remainder 1. 2 into 9 will give us 4, remainder 1. 2 into 4 will give us 2, remainder 0. 2 into 2 will give us 1, remainder 0. And 2 into 1 will give us 0, remainder 1. So we read it upwards. 39, okay, let's put it this way. 213 base 4 would be 100,111 base 2. Okay, we will be having it as 100,111 base 2. Alright, we have convert 4.25 base 7 to base 3. Now, in converting to base 3, we will first of all convert this to base 10 before we convert to base 3. Alright, remember that in converting 4.25 base 7, this will become 0, right? Since it's just one digit. And this will be minus 1, minus 2. Okay, so this becomes 4 times 7 raised power 0, alright, plus 2 times 7 raised power minus 1 plus 5 times 7 raised power minus 2. Okay, so this we are having as 4, anything raised power 0 is 1, so this will be 4 times 1 plus 2 over 7 raised power 1 plus 5 over 7 raised power 2. Okay, so this will become 4 plus 2 over 7 plus 5 over 49. Now our LCM will be 49. Okay, having our LCM as 49, this becomes 7 here, 7, 14 plus 5, which will give us 19 over 49. And 19 over 49 would have it as 4 plus 19 over 49, which will give us 4.388. Okay, having it as 4.388 base 10. Alright, now from here we'll convert from our 4.388 to base 3. Now in converting, remember we are using our division method. For 4, which is our whole aspect, will be divided by 3. Now 3 into 4 will give us 1, remainder 1. 3 into 1 will give us 0, remainder 1. So our 4 base 10 will be 1 base 3. Okay, bearing that in mind, one side. Now let's look at converting our 0.388 base 10 to base 3. Remember that when we are converting our decimal to a base, we multiply by the base which we are converting it to. So 3 times 8 would give us 24. So we write down 4, carry 2. Another 3 times 8, 24 plus 2, 26. Write down 6, carry 2. 3 times 3, 9. Plus 2, 10, 11. That makes write down 1, carry 1. Now, times 3 again. 3 times 4, 12. Write down 2, carry 1. 3 times 6, 18. Plus 1, 19. Write down 9, carry 1. 3 times 1, 3. Plus 1, 4. Okay, remainder 0. Alright, now we multiply by 3 again. Okay, 3 times 2, 6. 3 times 9, 27. We write down 7, carry 2. 3 times 4, 12, 13, 14. Write down 4, carry 1. Okay, we can decide to multiply again, or we leave it in this way. Either ways, we are still correct. Okay, so this, if we leave it in this manner, we can now say this to be, our reading will come down as 0.388 base 10 will give us 0.101 base 3. Now, since we have 4, since our work and our question says it's 4.388, okay, base 10, we are going to bring the digit for 4, which is 11.11. Digit for this would give us 11 plus 0.101 okay, all in base 3 now. This will give us 11.101 base 3. So our 4.388 base 10 will give us 11.101 base 3. Alright guys, hope you've enjoyed our lecture so far. If there are any comments or questions, please put them down in the comment section below. Don't forget to like, subscribe and share our links with your friends. Alright, thank you.